As the previous speaker said, this is real now. We have integrated IP Optical together, multi-vendor, and we've made it work, and we bear the bruises from that. We have the experience from that. And that experience of the problems along the way is what I'm here to share with you. First problem is the most popular router vendors are not the most popular optical vendors, which means any integrated solution is going to be multi-vendor. Different router vendors, different pluggable vendors, different line system vendors. I am going to talk through the implications of that with the help of Freddie. Freddie has his eyes on both IP and optical. He has both eyes open to manage the network together. To achieve that, you must integrate the different vendors across IP and optical. Let's talk about where that goes wrong. If you do not have both eyes open, you get misalignment. If you get misalignment, it's like building a train track like that, and we know what happens if you run a train down that. Life is not good. To get into specifics, your wavelength may be immediately dropped, or worse, you may impact a different wavelength. You may cut an existing revenue-bearing service. Get the wrong power, you may again impact an existing neighbor, or get the channel blocked. You may get inadequate signal at the destination. In other words, it breaks, or worse, it breaks something else. Wrong transmission mode, you're wasting spectrum, or again, it breaks. You must line up the line system and the plugs. You must get it aligned, you must keep it aligned, you must build your railway like that. Next problem. This is a quote from a Tier 1 operator in EMEA, which I'll read out. IP engineers now have to configure optical parameters such as center frequency, and depending upon the router, they may need to input values in nanometers, gigahertz, or megahertz. It's inconsistent across platforms. And IP engineers, frankly, are not particularly interested in learning about optical signal behavior. I'm a management guy. Let me put that in different terms. We need to normalize down to one representation, and then we need to abstract away that optical detail. So there's my problems. Let's start talking about what the world's doing about it. Here from the same heavy reading study is what people are doing. The top category, 38% of people are managing their pluggables via an optical controller. 35% are managing via a hierarchical controller. And you can read the rest. So in other words, 73% naturally will align their line systems and pluggables by integration. Others will need to take different approaches. What are we doing? We will support whatever our customer wants to do. We will provide building blocks towards that. What I'm going to talk about today, though, is the most popular one, the top option, the optical controller option. We will provide a multi-vendor, multi-layer management system by building on top of a unified abstract data model. Back to the carrier quote, we abstract, we normalize everything so we can provide one set of applications. We'll come back to that later. As an earlier speaker said, TAPI is widely adopted to normalize optical. Great, that's relatively easy. In the router space, we will go from open config plug management through Yang translation, then we can handle multiple routers and get down to those pluggables. There was earlier discussion of CMIS. We find that exceptionally helpful, that is quite well normalized and then sort of lost through proprietary Yang, but oh well, what can we do? The router vendors are gradually working towards wider adoption of open config there. So with properly abstract and transparent modeling, we can get that up to one representation, which is what we need. Looks nice, doesn't it? Let's talk about where it went wrong. Let's just say that I had to find an icon for explosions. We have spent 3 years doing this integration. We have done dozens of customer integrations. And we've had lots of little challenges. First one, routers particularly initially had very poor support for open config provisioning and optical PMs. The PM side has improved. We've recently seen things like Qfactor and BR much more present on the router side, but the provisioning not so much, so we simply had to take the hard route and use proprietary Yang. Some router vendors just do not expose inventory via open config, so we just had to use GNMI streaming instead. Some fear a router that is accessed via both an optical controller and an IP controller. Fair enough, so we simply hard partitioned the router using TACACS so that one controller could only access its bits and nothing else. Some people prefer read-only access to the routers. That's the tip mantra approach. We can do that. Cuts down the functionality, the ability to provision the plugs, but because we can read what's on the plugs and we can control the line system, we can still make sure they line up. We can still make sure nothing breaks. We can then monitor them and we can make sure everything stays aligned. You provision for 5 minutes, you monitor for 20 years. That only works because of the multi-layer, because we can put together the plug status and the line system status. Finally, some routers have very limited alarm support on the optical side. Optical people love alarms and have hundreds of different ones. The routers pretty much have the link failed, and that's it. However, the line systems have much more detailed information, so again, Freddie pops up. By merging together the information from the line system, we can go from simply, it's down, to here's why it's down, which is what you need. All right. That means that the tools that the industry has taken 30 years to develop in how to manage optical on their transponders are now available on routers, just by adding in that adaptation. So if you look at this view, you will see this is a typical optical management view, an end-to-end path of a wavelength, listing every single optical component along here, except there's some new ones. There's third-party routers extended right out to the QSFP-DD pluggables. We can go on from that. Really detailed optical management tools like this, which is looking at how power changes as you go along the line. You lose power every time you go through unamplified components like wavelength selective switches. You gain power every time you go through an amplifier. Any optical troubleshooting probably needs a view like this. Again, this is a tool that has been there for years, except now it's got a third-party router on each end. This is the value of that abstract normalized modeling. On the next slide, I have been having a lot of fun at this conference teasing service providers about their IP operations team and their optical operations team and how they simply do not talk to each other or do not communicate and will lose tickets between each other and will get things wrong and will delay and hold things up. That's not how it should be. What you need is to work from one view, both people working one view which speaks both of their languages, a cross-layer view. That should quickly get you down to a simple problem solution. Here's an example of that. You can see we have IP or Ethernet links at the top. You can see we've got an IP link failure. That has triggered the troubleshooting process. However, we have also got the optical line system here. In this case, there are very few optical alarms there. You can see the complete correlated alarms list up there on the left. However, there is one alarm on the optical system. It's that orange one there, and what that is saying is, I'm a filter and I'm getting no power. So that pretty much instantly tells you it's the plug, it's not sending power, you need to look at that plug. So this is telling you where to drill in and who should drill in. This is telling you the IP guy needs to get on that router and have a look at that plug. Contrast that with the next view. This is an optical layer type failure, and I think you'll agree it's immediately obvious that it's different. You've now got red coming right up from that optical layer. You've got a totally different set of alarms down the side. Anyone looking at this can see, yep, okay, the optical guy really needs to look at this first. This is one view. It has IP addresses on it, it has Ethernet ports on it, and it has wavelength IDs, and it has amplifiers on it. When you are troubleshooting, one view, everyone looks at together. What used to take weeks of bickering as to whose problems it was, can now be seconds. This is reusing these tools by that abstract modeling. So next, changing from operations to planning. Very common topic is how much wavelength bypass you do. I'm sure many of us are familiar with this sort of comparison. If you simply do hop-by-hop routing, then you end up using lots of coherent pluggables, and we sell coherent pluggables, and we would love to sell them to you, so go for it if you want to take that approach. Take the opposite view and minimize those if you like, and that uses more line system capacity, which has some cost there. But we all know the lowest cost answer is always in the middle by doing cost optimization across those layers. Or to put it another way, single layer planning is driving with one eye shut. You are throwing money away. So, to summarize, multi-layer management, we have made it work. We have made it work using strong model-based design. We have used OpenConfig in order to make it work well. Because we have done this, we and the industry are able to use the tools that exist today, that the optical operations people are extremely familiar with, that are powerful, that are field tested, except now we can do it with routers. Now we can do it with the plugs in those routers. By doing so, we get savings from that cross-layer operations, we get savings from bringing together those two teams, and we get savings from simple CapEx of that cross-layer optimization and planning. And to summarize the summary, don't drive your network with one eye covered. Manage the IP optical together, open both eyes, and point them at the Ciena booth, where you can see this in action, and from 5 o'clock with beer and wine. Thank you very much.